This is the practice test for advanced math, and right now we're going over 6, 8, 9, 10. Okay, starting tangent function.
Yes.
Yes? Okay, it is a tangent function and it has an A and a B. Can you see that right here?
Yes.
Okay, so let's see. It should be tan A plus tan B and then 1 minus the product of the two. Is that the way it is, or has it been flipped around? Now, it's important to recognize when it's flipped on the negative sign versus flipped on the fraction. This compared to this is what? Flipped on the negative or flipped on the fraction? When you flip on a fraction, it's the reciprocal. What's the reciprocal of tangent? Cotangent. If it had flipped on the negative, then it would have been, if like say it stayed like this, but the denominator was flipped around, it would be negative tangent. All right, cotangent of A plus B, so 12 plus 10. What's our final answer? Cotangent of 22. Okay, number 8. What you want to do with these is recognize the difference from, say, number 2 and 8. The obvious difference besides it being flipped, does everybody see that it's flipped on the negative? That aside, ignore the flipping on a negative. There's something else that's different, and it's a big difference. The 2. The 2 makes all the difference. When it's a 2, it's a double angle. Is this a double angle? No. That there is using an old Pythagorean identity that we learned last unit. So if I have 1 minus cosine squared, 1 minus cosine squared, what would it equal? Sine squared. No double angle, just sine squared. Sine squared of 27. And that's it. No double angle, just sine squared 27. Make sense? All of these little tricky type problems will be on the test. Okay, 9, I did with you in a set of notes. I don't know if it was lesson 5 or 6. It was on the back page. I said I had review problems, and I told you guys a lot of kids missed this on the test. Does anybody remember what I said about what the mistake is that they make? What do they do to each one? They expand it. They expand, FOIL, and they end up with a big mess. Notice that you have sine, cosine, sine and cosine. These two are the same, and these two are the same. So what is it going to be? Can we condense this into a single function? Is it sine, cosine, or tangent? Sine. It's plus, so technically it doesn't matter which one's A or B, but we should remember that A is always with the first sign. So 160 plus x and 20 minus x. Is there anything to distribute in either of those parentheses? No? Combine like terms. What happens with the x's?
Cancel out.
Cancel out. So that leaves me with sine of what? 180. And is 180 a special angle?
Yes.
What is sine of 180? 0. Got it? Okay, any suggestions on number 10? No? Can we take out a negative 4? Okay, if you didn't see the negative, then just take out a 4. But taking out a negative 4 is correct. That leaves me, if I'm taking out a negative 4, you guys okay if I flip it around?
Yes.
Positive 1 minus 2 sine squared 22.5. Negative 4 times 1 is negative 4. Negative 4 times negative 2 gives me the positive 8 sine squared. Now, how many of you didn't take out the negative 4 and just pulled out a positive 4? Anyone? Would it still work?
Yeah.
Yes, yes it would. All right. If you pulled out a positive 4, it would look like that right there. 2 sine squared minus 1. Okay. Regardless of the method you used, can you see that it's one of these here? Pulling out the negative leaves it 1 minus 2 sine squared. Is that the proper form it is supposed to be? Yes. So I change it to cosine of double the angle. So negative 4 times cosine of double the 22.5. If you didn't pull out the negative, you would recognize that it's negative sine. Or sorry, is that the right one? Am I on the right one? Negative cosine. I wrote it incorrect here. You would recognize that it's negative cosine. Let me show you on this one. If you did not factor out the negative, that would be flipped around, and you would recognize that it's negative cosine. Got it? Okay. What does that become? Negative 4 times cosine of what? And is 45 a special angle? Negative 4 times, what's cosine of 45? Forgot my negative. Root 2 over 2 or 1 over root 2, does it matter how you write it? No. And then I multiply, negative 4 times 1 is negative 4 over root 2. Got it? Questions on that one? No questions? Okay, let's flip over to the back page. Let's start with actually anything from the back page. Number 4. Okay, there's multiple parts, so let's break it up, sorry. 1 through 15, we'll start there. Questions on, 13 to 15. No questions. Questions on part 2. 4. Okay, and I'm only going to do those 2 because 1 is similar to 2 and 3 is similar to 4. So if I show you 1, you should be able to do number 2. And if I show you 4, you should be able to do number 1. All right, expand. Sine of 3 pi over 2 times sine or cosine? Cosine of theta plus or minus sine of theta and cosine of 3 pi over 2. 3 pi over 2 is 270. Do you agree? What is sine of 270 or sine of 3 pi over 2? So this whole thing here becomes negative 1. What's cosine of 3 pi over 2? 0. So I have negative 1 times cosine theta. What's negative 1 times cosine theta? Plus, what sine times 0? Do I have to put plus 0? No, that there is my final answer. And it comes up very similar on this one. You would expand it, cosine theta, cosine pi, plus sine theta, sine pi, and evaluate it. All right. On these, when you see these on the test and they don't give you anything other than just the angle, that's where you break it up into 2 special angles. And it will always be a 45 as one of them, 45 plus something. For us in this class it will be. So in your head, on your paper with your calculator, 45 plus what is 225? 55, sorry. What is it? 210. And once you do that, both of them should be special angles. Are both of those special angles? Okay. So we have tangent of 45 plus tangent of 210 over 1 minus the product of the 2. Okay, what's tangent of 45? Plus tangent of 210 is either in your head or on your unit circle. What is it? 1 over root 3. Tangent of 210 over 1 minus 1 times we just found tangent of 210 to be 1 over root 3. 1 plus 1 over root 3 and 1 minus 1 over root 3. How do I clear a complex fraction? Multiply by the common denominator, which is what in this case? We spend a whole unit on this type of stuff during the beginning of the semester. The unit you all loved. Root 3 plus cross out 1 over root 3 minus reduce 1. And that is your final answer. You can multiply by the conjugate to rationalize, but you don't have to. Questions on part 2? All right, part 3, numbers 1 through 3. Questions on any of those there? Number 1? All right, any suggestions on number 1? He said factor out a GCF. What's my GCF here? Sine 2x. 2 cosine x plus what? Equals 0. I can now use the zero product property because it equals 0 and I've already factored it. Sine of 2x equals 0 and cosine of x equals negative 1/2. When I'm solving and there's a 2x, what does that mean? I go around my unit circle how many times? Twice. First time around, what are my 2 angles where sine is 0? 0, 180. There was a mistake here. That equal bar should not be there, and it will not be there on the test. It should only be on the 0, not the 360. Okay. What do we do to each one? Before dividing by 2. Add 360. Good job. What's 0 plus 360? And 180 plus 360? And now you guys said it earlier, divide everything by 2. X equals 0 divided by 2 is 0. 180 divided by 2 is 90. 360 divided by 2 is 180. And 540 divided by 2 is... And if I stop here and box this all in, why would I get it wrong? There's still 2 solutions right here with the cosine x equals negative 1/2. And what are they? 120 and 240. Thank you. Okay, questions on that one? All right. I won't do these all the way through because you guys should know how to solve them, but does anybody need help with setting either one of those up, like at least how to start it? Number 2? I need to solve it, and in order to use a zero product property, I will have to subtract that 1 eventually. But what am I going to change on the left-hand side? The cosine 2x. Now, how many possibilities do I have for the cosine 2x? 3. Pick one. If I have a sign there, which one should I pick? The first, second, or the third? Second. 1 minus 2 sine squared x, that's the cosine 2x, plus sine x equals 1. Oh, and what did I say I was going to do with that equals 1? Subtract it over to get it equal to 0. All right, what ends up happening with the 1s? Leave me with negative 2 sine squared x plus sine x equals 0. What can you do at this point? Put your phones away, guys. This is all of this stuff. It's a pretty heavy test, and it's not a block day test, so you need to make sure you're ready. You don't have time to sit there and, oh, what do I do, and try to remember. And you need to have it in your head and ready to go. What do I do here, guys? What is that? Take out a sine x. Do you guys agree? Okay, what does that leave me with? Negative 2 sine x. Gone or plus 1? Plus 1. Plus 1. Did anybody take out a negative sine x? And is it okay if you did? Yes, you'll get the same answer in the end. Zero product property, you can finish it from here. Sine of x equals 0, there's two solutions. Sine of x equals 1/2, because after you subtract and divide by the -2, it's positive 1/2. Solve and solve, you end up with your 4 answers. Got it? Anybody know what to do on number 3? I hope that. Contract it, condense it. You see sine and cosine, sine and cosine. Can you condense it to the sine function? Yes. All right. Next page. Questions on 4 before I move on to part 4. Questions on number 4. Is that another condensing one? Yes or no? It's flipped. Go ahead. It's flipped on the addition sign, because it should be cosine, cosine, and then sine, sine. Oh, sorry, out of screen. It should be cosine, cosine, and then sine, sine, and it's flipped on the addition sign. Does it matter? No, it's going to be cosine of, oh, that's a good one to talk about. Cosine, and it's plus or minus? Which one's A? How can we tell? Okay, she said it's the first in the cosine, but technically, can these be written flip-flopped? Cosine is multiplication is commutative?
It doesn't matter.
He's saying it doesn't matter. What's 2x minus 1x? X, and if I put x minus 2x, which is not the way I did it. I did it 2x minus x, but what if a kid said this is A and this is B? What's x minus 2x? And what happens with cosine of a negative? Absorbs. When the cosine's out front, it does not absorb it. If it was negative cosine x, it doesn't. But cosine of a negative is gone. So does it matter with cosine which one's A and which one's B? Does it matter with sine? Yes, yes it does. The sine does not absorb the negative. All right. And there's one answer. You can find that one. Part 4, numbers 1 through 3.
You do 1 and 2.
1 and 2. I definitely want to do 2. Number 1 is, I will do if needed. It's like this one here where you expand. And 3 is a definite on the test. This is the one where you have to write down in words. Do you guys know how to do those?
I have a question for number 3.
Mm-hmm.
Can you can you just draw the graph? Because I don't understand how it's not included.
Oh, you know what? I'm glad you asked that. My last class had the same question. Okay, before I do that, let me come up here to number 2 really quick, and then talk about 1. I'll at least set it up. Shane, did you say you need to see that one?
Yeah.
Okay, so cosine pi cosine theta plus sine of pi sine of theta. Can you simplify cosine of pi? Thank you. Who said it? Good job, Emily. Why is it minus? Can anybody else besides Emily tell us? Cosine's opposite. Good job for both of you. All right. Questions. What is cosine of pi? -1. So it's going to be -1 times cosine. Minus what sine of pi? 0 times sine. What's going to happen to all of this? Goes away.
What are you doing? Oh, she's just doing the best.
Yeah. I know, I looked at the wrong one myself, so it's the plus sign in the parentheses. Okay, and then minus parentheses and write your sign out. Sine theta cosine 3 pi over 2. Take away sine 3 pi over 2 cosine theta. You're going to distribute your negative, and then we already talked about simplifying this one or evaluating. You're going to evaluate these as well, the cosine of 3 pi over 2 and the sine of 3 pi over 2, just like you would have over on these. Can you guys finish it from there? All right, this next one is a bit tricky, and it comes up on the test for sure. Okay, I don't have a sine 10x formula, and I'm going to use theta for the sake of this problem. What does sine 2 theta expand out to when you use your angle or your double angle formula? Sine up, yes, you are correct, but I'm just talking about the two sine theta cosine theta. Agree or disagree? Agree. Okay, so how can I make sine of 10x into sine of 2 times something? 2 times what is 10x? Sine of 2 theta. What is theta in this problem? 5x. Do you see that? Sine of 2. My theta is the 5x. So sine of 2, and again, theta being 5x, would be the 2 stays 2. Sine of, and what did we just say theta was? 5x, and cosine of theta, which is still 5x. 2 sine 5x cosine x. What letter is that? B. Questions?
Can you show what it would be like for AB?
What it would be like for A? There wouldn't, it would, yeah. It would have looked like something like this. Sine of 4x, and then something like 2.5 in the front. Yeah, it's not, you're not going to see one like that. Okay. So, quick side note, what if this was sine, let's say it was a sine 4x. What would that be? Sine of 2 times what? 2x, which would be 2 sine of 2x cosine of 2x. All right, should you know how to do that? Yes. All right. Questions? All right, number 3, the whole not acute angle. Cosine of theta is 5/13. Where is cosine positive? Quadrant 1 or quadrant 2, 3, or 4? 1 and 4. So I know it's not going to be in 2 or 3. Ignoring our pictures, just acute angles. Where do all the acute angles lie? In quadrant 1, 2, 3, or 4? 1, because acute angles are angles less than. Okay. So can I draw my theta in quadrant 1? So I'm going to draw it which quadrant? 4. Now technically, we've been getting, like in the beginning, we made a big deal about it, but lately we just put theta. Technically, from here all the way around to that is the real true theta. And in here, in the beginning, like unit 3, we call that theta prime. Lately, we just call it theta, but that is your reference angle. The true theta is bigger than 90. Can you see that? From here all the way around. Yes or no? That's a reference angle, which we could call theta prime. We just call it theta because it works out the same way. Does that make sense? All right, cosine is 5/13. Pythagorean's theorem, anybody have it already? 12.
Negative.
Only one person stopped me. Do you guys see that it should be negative? I need you guys paying attention. This is on the test. When you do Pythagorean's theorem, are you going to get a negative 12? No. Should you know it's a negative 12? Yes. Okay. Sine of 2 theta is nice because there's only one possibility. 2 sine theta cosine theta. I have kids every year, and I'm not sure where the mistake is made, but they'll write sine of a fraction, cosine of a fraction. No. Sine of theta, cosine of theta, which is 2. Now you plug in your fractions. What is sine of theta? Negative 12 over, and then cosine of theta is what? All right, so you don't plug your fraction in until after this sine, not sine of a fraction, it's sine theta, cosine theta. And then your fractions, once your fractions are in, there's no more sine and cosine. 2 times 5 is 10, times negative 12 is negative 120 over 169. On the test, it'll be something like this with a blank, and you'll write negative 120 over 169. Make sense? Okay, part B. 2 theta is in which quadrant? Who remembers how to do that? What is that? Good. Okay, they both said you have, okay, I already found the sine 2 theta, so which one should I find next? Cosine. What if you did find cosine first? What would you find second? Sine. Okay. How many choices do I have for cosine? I have 3 choices? Does it matter which one I use? No, pick one. Cosine squared theta, he was the first one to answer, minus sine squared theta, equals blank squared minus blank squared. What is cosine of this picture? 5/13. What is sine of this picture? 25 over 169 minus positive 144 over 169. All I care about is whether it's a positive value or a negative value. That's all I need to know. Negative. All right. Who can tell me which quadrant it is in if sine of 2 theta is negative and cosine 2 theta is negative? Quadrant 3? Everyone agree? Is that what you said? Okay. So part B, you would put the Roman numeral 3 or Q3, totally up to you. Who can tell, who can explain why? Because you need to be able to put it in words. Who can explain how we know that it is in quadrant 3? Good. So you would say something along the lines of sine 2 theta, that's the first one we found, came out to be a negative. And then we went on to find cosine 2 theta, which also came out to be negative. Therefore, it must be in quadrant 3. I'm going to run out of room. I'm going to draw it down here. Because sine was negative, we knew it wasn't in these 2 quadrants, correct? What if the second one, what if cosine came out to be positive? How would I know which quadrant it's in? Is this the only quadrant here that it could be in? Yes, because that would have been the only place where sine was negative and cosine was positive. But because they're both negative, quadrant 3 is the only place where both sine is negative and cosine is negative. In your explanation, should you put anything about this acute angle? No. You will get it wrong. If you say anything about it can't be in quadrant 1 because it says it's not an acute angle, wrong. When they're talking about the acute angle, they're talking about the original theta. Down here, am I asking you about the original theta? No, I'm asking you about which one? 2 theta. Double the angle. I'm not asking about the original theta. I'm asking you about 2 theta. Does that make sense? All right, back page. Questions on 4? 4 is a GCF. Can you guys see that? What can you take out? Sine 2x. And when you're left, once you solve, you're going to square root, which will give you a plus or minus, which means all 4 quadrants eventually. All right, you guys got number 4 okay? All right.
Wait, what are you supposed to take out?
So we take out, can you guys tell me again what you take out? Sine 2x, leaving behind a 4 cosine squared x. Is that it, or minus 1? Equals 0. Sine 2x equals 0. Cosine squared x equals 1/4. And right here, this is ready to solve. Remember, you're going around twice. This one, when you square root both sides, what do you have to put in front? Which means how many quadrants are you going to be in? All 4. cosine x equals plus or minus 1/2. All right. Shall we go over the true false questions? My morning class said that they were kind of difficult.
Oh, yeah.
Okay. I will tell you this. Some kid asked, "What am I doing? Am I like doing it like a proof? Am I solving?" You can treat it like a proof, yes. And if it works, it's true. If it doesn't work, it's false. You can move things around. You can manipulate it. But I'm going to work with the right-hand side and check cosine 2x. Well, I'm trying to prove or show that it equals this. So what should I change it to? Both sine, cosine, just the cosine, or just the sine? So 2 cosine squared x, what is it? What is the formula? Minus 1, and then the plus 1 is still there at the end. What happens with those two? What does that leave me with? True or false? True. 2 cosine squared x equals 2 cosine squared x. Okay. What other one did you guys say was a little tricky? 3. Is number 2 true or false? There's not really much work to do on that one. It's just trying to get you to recognize when we have this, is it ever okay to divide both sides by 3? Is that something we've ever done? When am I allowed to divide by a coefficient? When the coefficient is where? In the front of sine or cosine. When it's on the theta, you cannot. So this is false. Okay. 3, anyone want to approach it?
Foil?
Foil? Is that what you guys are saying? Okay. Sine theta minus cosine theta times what? Right, minus. It's not plus. It's not a conjugate problem. Sine squared minus sine cosine is minus 2 sine cosine plus cosine squared or minus cosine squared. Are we good? Okay. Any suggestions? I hear one of you whispering it. If we were to rearrange, what could happen? It's an identity. Sine squared plus cosine squared is? So I have 1 minus 2 sine theta cosine theta. I'm trying to get it to look like that right there. What can I do next? Make it look like that. This sine 2 theta, and is that what we're trying to compare it to? So true or false? So you can see some of them are pretty easy, some actually take a bit of work. Number 4, recognizing all the flipping. Okay, did this, I'm going to cover this. Did this fraction flip once, one kind of flip or 2 kind of flips? Did it flip on the fraction? So that's cotangent. Did it also flip on the negative? So that's negative cotangent. Is that what they gave you? So true or false? That there should be negative cotangent of 80 in order for it to be true, because it flipped on the fraction and flipped on the negative. All right. 5, there's more than one way to approach it. Anyone have any suggestions? No suggestions? What is that? For sine squared? Okay. He's saying take sine squared and change it to its identity. So no, that's not what you're saying.
Do that, but you just flip it, make it opposite, and just do the cosine.
Okay, you're saying the whole thing is the identity. Yes? All right, I see what you're saying. Okay, so he's saying sine squared x plus cosine squared x equals 1. If I put sine squared minus 1, what would it equal? Cosine squared or negative cosine squared? Do you see that? If I move over the 1, I'd have to subtract that. So negative cosine double the angle or just cosine squared? Just cosine squared. Does that equal negative cosine of 36? No. True or false? This actually looks a lot like I'm going to cover that, and I'm going to show the formulas. Can you tell me why I could not use this formula here and say, well, this looks like this, but it's flipped on the negative, therefore it's negative cosine of double the angle. Tell me where I messed up. I'm going to repeat it. This looks like this, but it's flipped on the negative, so it's going to be negative cosine double the angle, and there it is right there. Negative cosine double the angle. It must be true. There's no what in front of the sign. If there was a 2 there, would it have worked? Yes. Without that 2, it is not a double angle, it's a Pythagorean identity. So it is false. Questions? Do we need to see 6 or 7? Yes or no? Number 7? Number 7, I'm going to pick the left side, and I've done this one in notes. I've done this one with you guys in homework. We've talked about it. I'm going to do it again, but I just want to make sure you guys understand it's something you need to know. Now, when I pick the left side, can I also change the right side? No. But kind of thinking off in your head, you're not changing it, but you're in your head processing. Cotangent is what over what? That will help you figure out what to change. Because I always have kids ask, I don't know which one to use for the cosine. How am I supposed to know? They're all going to work, but there's always going to be one that works a little quicker and easier. If I'm trying to get cosine squared at the top, what should I change it to? The one with the cosine squared. 2 cosine squared x minus 1. If I'm trying to get sine squared at the bottom, what should I change it to? 1 minus 2 sine squared. That kind of, so you're looking to the right side as a guide to help you with what to use. 1 plus 2 cosine squared x minus 1, the 1's cross out. 1 minus 1 plus 2 sine squared x, the 1's cross out, the 2's reduce, and I'll let you guys finish. Make sense? Yes? Okay. Do we need to see number 6? Yes or no?
Yes.
Right side or left side? Cosine 2x is what I'm going to change. Plus 2 cosine squared x minus 3. Any suggestions on what to change it to? 2 cosine squared x minus 1. I can combine it with this, yes or no? Do you guys see how that worked? Pick one. The one I heard first was 2 cosine squared x minus 1. There's nothing to distribute, so I'm just going to rewrite it and combine like terms. What combines? What does that combine to? 4 cosine squared x minus what? Can we factor out a 4? Cosine squared x minus 1. I'm going to cover the 4 out front. Is this a double angle or Pythagorean identity? Because there's no what in front of the cosine squared. Because there's no 2, it's this one right here. Cosine squared minus 1 is positive or negative sine squared? So negative 4 sine squared x, and is that what we're trying to prove? Questions? Where did I get what? The negative's coming from right here. If I were to get cosine squared x minus 1 over, I'd have to move the sine squared over. Do you see that? Okay. Any others? We're good?